Good morning and welcome. I'm super excited to be here today to talk about data and AI. If we cast our minds back just a couple of years ago, most of the conversation was about generative AI. What can I build? What can I summarize? What cool application can I build? But listening to customers over that time, there's an emergence of, well, actually, to really gain value out of my generative AI outcomes, I need to harness my data. And my data comes in multiple different formats, structured and unstructured. And it's an increasingly challenging, complex, and chaotic world where data is growing exponentially. Just in this room alone, there's probably over 366,000 gigabytes just of data on our mobile phones alone, not including the laptops or iPads that we probably have with us as well. And it's growing year on year. What if we could get order amongst all this chaos and streamline this to make using our data effortless, to make our AI performant, and then ultimately unifying these together into a single interface, a single platform to build to generative AI outcomes, analyze our data, and build new emerging generative AI applications. Let's start with data. Some of the most innovative developments that we're working with our customers day in, day out has actually started with data and databases. Our teams wake up every single morning saying, how can we optimize? How can we actually remove the heavy lifting for you, our customers, to build the next generation of generative AI and AI outcomes? At AWS, we have the most complete and broadest set of database services. We have the relational database services from RDS and Aurora, or custom-built databases such as DocumentDB and DynamoDB. And we're not stopping there either. This isn't just something that we've thought about overnight. For the past 15 years, we've been focusing and building on databases. It started with managed databases. We wanted to remove the heavy lifting for our customers and yourselves to have to manage your underlying database instances. Moving forward, we then moved into serverless to eliminate the need to plan, provision, and manage your database capacity as your applications scale. And we're still not standing still. As Sundar touched on with this last presentation, we now have four active multi-region databases to support your varying application needs. From Aurora DSQL, from DynamoDB global tables to key spaces and MemoryDB. Adding multi-region active capability enables you to build your applications at a global scale. We're making databases effortlessly for you to use and build your applications. And fundamentally, it doesn't matter where the data's landing, you are always in control of your data. We've expanded this as well, not only providing global active capability, we've also increased the performance. We recently launched Aurora Postgres Limitless Database, providing automated sharding with millions of write commit transactions per second, all within multi-petabyte single databases. But it's all very well having some of the best and broadest services, first party. We hear a lot from our customers who are wanting to optimize their Oracle investments. How can I get the scale of Oracle Exadata? How can they leverage the security, capabilities, and agility of AWS? And fundamentally, how can they gain the benefits of synergizing the data together from Oracle and AWS? And fundamentally, how can we then use that to build the most innovative generative AI outcomes? Which is why it's awesome that we've recently announced Oracle databases at AWS in limited preview, just to enable our customers to start expanding and scaling their generative AI outcomes. But it's all very well having the services there, but how do we get the data onto platform? One of the most risky, time-consuming, and potentially costly processes with databases is migrations. Our customers have been asking us to invent and simplify this process on their behalf, which is why it's awesome to announce that we now have AWS DMS schema conversion with generative AI. This now enables you to convert and make more accurate and upload the data from an original database to the latest database, enabling you to migrate and modernize your data. Just for example, migrating from a SQL Server to Aurora Postgres, DMS can convert over 90% of your database code and architecture. But it's not only our services. At AWS, we are committed to the open source community. We believe that committing to the open source community can fuel the next wave of innovation. In fact, in 2024, we made 1,399 accepted contributions back to the open source community, whether that was with MySQL or MariaDB or Valkey. These contributions enabled us to launch version 8 of Valkey in November last year, introducing new I/O throttling and threading architecture, which improves the parallelism and efficiency and performance of your underlying data. In fact, it can deliver up to 230% higher throughput and up to 70% better latency compared to Valkey 7.2. And we're not standing still. We're going to continue to contribute to the open source community. Actively contributing to Valkey, we believe we can make it the most performant, in-memory, key-value open source data store. And again, inventing and simplifying, working with partners, open source community, our own services. We're also looking at increasing efficiencies of our services, which boils down to cost savings and price reductions. I encourage everybody in this audience and all of your builders to explore how you can take advantage of some of these cost savings to then fuel the next wave of innovation. Okay, so we've touched a little bit about making your data effortless, building more, going global, performant, migrating in, and working with some of the largest database providers in the world. But I'd like to touch on now, how do we make AI performant? Since 2010, the training compute required to build the latest models has gone up 4.5 times each year. In fact, to build some of the latest generation state-of-the-art models today costs hundreds of millions of dollars, half of which is often attributed to GPUs, and then the rest to hardware and underlying energy. This trajectory is worrying. We need to start inventing, simplifying, and coming up with new AI infrastructure, AI components to be able to fuel the next wave of innovation. We haven't just started thinking about this either. For the last 10 years, we've been investing and researching into our own chipsets and architecture. This has boiled down to 2 chipsets that you'll see available today. The first one is AWS Inferentia. It's a chipset really geared and focused more for your inferencing workloads. The second one is AWS Trainium, and as it says in the name, it's very much geared towards your training workloads. And not only that, we are continuing to evolve and invent in this space. So much so that at reInvent, a couple of months ago, we just announced the 2nd generation of AWS Trainium to accompany our 2nd generation of AWS Inferentia. And our customers are realizing this as well. Anthropic trained their Haiku 3.5 model on the Trainium 2 chipset and reported it to be training 60% faster than other equivalent chipsets out on the market. So I encourage everybody in the audience who are ML builders, ML engineers, looking to leverage the latest chipset, but at a high performance, low cost, then to start exploring how you can leverage the AWS Trainium and Inferentia chipsets. But even with these chipsets, building the latest models requires more than just one compute. There's a varying number of compute instances you require. And this is becoming unwieldy. How can we manage our full ML infrastructure, multiple compute instances and still gain efficiencies? E.g., how do we ensure that all of our investments are being fully utilized? We hear from customers that are struggling with this today. They have multiple compute instances costing a lot of money, but they're not fully utilized. We experienced this ourselves at AWS. And so we started investigating how can we actually fix this problem for ourselves to then help customers. And we did just that. With our own evolutions with SageMaker and SageMaker Hyperpod, we launched an ability to actually increase our compute utilization across Amazon up to 90%. The next thing we hear from our customers is, well, I'd like to use that as well. How can I take advantage of this? Which is why it was awesome that we further expanded our SageMaker Hyperpod capabilities at re:Invent to launch flexible training feature. You can quickly create a training plan, automatically reserve capacity, assign which data and clusters you want to run, and then create model training jobs, and then let SageMaker Hyperpod just manage this all on your behalf. So we've covered training. Training is an important aspect, but many of us, many of the end customers, many of the end users of the applications you build are going to be interacting with inference. Inference is where the model now leaves the lab. It goes into the wild and starts generating awesome outcomes, potentially saving lives, creating productivity and efficiencies within your own organization. But there's challenges. Inference is rapidly evolving. How do customers take advantage of this? To be able to inference in the modern world takes sophisticated tools. Many ML engineers and scientists are able to use these tools, but often the developer who is tasked with building generative AI applications doesn't have this capability. Which is why it's awesome that we launched and made available Amazon Bedrock, which is available here in the BOM region in India. Amazon Bedrock is the easiest and fastest way to build and scale generative AI applications. But how does it do that? By 5 things. The first, we provide choice and flexibility of which model to use. We then optimize for cost and latency when you're building applications. The third element is we enable you to leverage your own data to improve the value and generate better outcomes of generative AI. The fourth component is we apply safety and responsible AI into the build as standard. And finally, we enable you to then orchestrate multiple data components and other API calls into a final orchestrated generative AI outcome. But how do we make it easy choosing models? We have the broadest, deepest set of model providers available on Amazon Bedrock. Some of the largest, most innovative builders from Cohere, AI21, Anthropic, Meta. And we didn't just stop there as well. We leveraged our own investments, our own infrastructure to introduce our latest family of models, the Amazon Nova family of models that was launched more recently at re:Invent last month. Nova family of models provides 6 models, ranging from multimodal capabilities, image and video generation, through to one of the highest performant, cost-effective text-to-text models around. However, it's not just about choice. We need to start thinking how can we actually help our customers evaluate these models. A key element in any evaluation is around cost and latency, but it's a delicate balance, as optimizing for one typically has a counter impact on the other. This is because more cost and response inversely correlates with model accuracy, as more intelligent, capable models consume more accelerator hardware. At reInvent, we introduced 2 new features to help you build more effective outcomes using Amazon Bedrock. The first is model distillation. This is where you can leverage one of the leading, highly capable models available on Amazon Bedrock and then distill it down to a much smaller, high-performant and cost-effective. We've seen that building smaller, more geared models can actually operate 500% faster and even 75% cheaper to run. The second element we launched as well was latency-optimized inference options for Bedrock. Before you had to select which instance type, you were maybe geared to a single instance type to use. What we've now enabled is removing that options and availability to leverage our own capabilities